Well, hello, dear algebra class. Sorry to miss you. I hope that this lesson serves you well. We're going to do two sections today that I'm going to instruct you on directly up front, and then you've got two assignments here that you can work on. If you finish them today, then they won't be homework, but if you don't, you want to finish them over the weekend. As always, when you do your assignments, I want you to score your paper. So if you get 20 out of 22 correct, I want you to write that there, and then you're going to tell me whether you have a negative, a check, or a plus. Plus would mean you understand everything. You are good to go. Doesn't mean you got everything right the first time, but it means that when you checked your answers, you could figure out why you got them wrong, and you feel like you have a good understanding. Check means maybe there's a few that you don't understand. Most of it you do, but not all of them. Minus would mean more than not, you just don't understand. So that means less than half of them make sense to you. Okay, want that at the top of your paper. At the end of class today, if you finish, you can give it to the substitute, or you can bring it on Monday and show me how you did, so I'll know how to teach you moving forward with the next lesson, or if you need help in tutoring on Monday or Friday after class. Okay, so let's take a look. This is section 6.4 and 6.5, and they have to do with getting common denominators between fractions that have variables and polynomials. You've done common denominators before. For example, let's say you had a fraction that was in sevenths and you wanted to express it in 35ths. To do so, you have to ask yourself, how do you get from 7 to 35? Well, you do that by multiplying times 5. If we multiply the denominator by 5, we must multiply the numerator by 5. If I do that, I get 15 35ths. So this tells me that 15 parts of a 35-part whole is the same as 3 parts of a 7-part whole. Or if I had a slice of a whole pizza and it was sliced into 35 equal slices, and I ate 15 of the 35, that would be the same amount of pizza eaten as if I ate 3 equal slices out of a 7 equally sliced piece of pie. Any fraction, for example, 30 over 70, any fraction by which you derive its numerator and denominator by multiplying them by the same number is going to be equal. So 3 sevenths, 15 35ths, 30 70ths, 60 1/40ths. I just multiplied times 2 again. Those are all equal. So you've learned that principle before. Well, let's do that with some variables involved. 8 over 3a equals something over 18a squared. We'll ask ourselves the same question. How do you, by means of multiplication, get from 3a to 18a squared? What did we multiply to get there? It looks to me like that would have been a 6a. 3a times 6a is 18a squared. So if I want to make this an equivalent fraction, and I do, I must multiply the numerator by the same value that I multiplied the denominator, which is 6a. So 8 times 6a is, let's erase this question mark and put our answer. It is 48a. Well, I have 48a over 18a squared is equal to 8 over 3a. Now don't go reducing things. No factoring, no reducing. The whole point of these is just to write an equivalent fraction by using a common denominator. Here's another one. Takes it a step further by introducing some polynomials. What if you had 2 over x minus 5, and you wanted to write an equivalent fraction that had the denominator x minus 5 times x plus 1? Well, I'd ask myself here, what did I have to multiply x minus 5 times to get to x minus 5 times x plus 1? Well, couldn't be more obvious that I multiplied it times x plus 1. Well, if I did it there and I want an equivalent fraction, I must also multiply the numerator times the same thing. So I'm multiplying it times x plus 1. So 2 times x plus 1. That is an equivalent fraction to 2 over x minus 5. Now here's another way of helping you find the least common denominator when the least common denominator is not so easy to find. Here's one with just numbers. Let's say you had 3/4, 11 30ths, and 7 45ths. In order to find out, now you might know off the top of your head that that's 180 is the least common multiple. The least common multiple is the same as your least common denominator. If you can find the least common multiple, that is the answer that you get when you multiply all three denominators by the same number. If you can find that least common multiple, then you can get to your least common denominator. But one way to figure it out if you can't quickly do it in your head is to factor each of the denominators down to their prime factor. So this would be 2 times 2, or 2 squared. For 30, let's say you did 3 times 10. 10 could be 5 times 2. So we have 2 squared. We have 3 times 5 times 2. And 9 times 5, we'll bring the 5 down. But 9 can become 3 times 3, or 3 squared. So we have these three denominators factored. We have 2 squared, 3 times 5 times 2, and 3 squared times 5. My common denominator for these three fractions is going to be the product of the highest power, or exponent, of each of these factors. So I look at the 2's and I say 2 squared is my highest power of 2's out of all these factors. And then what's my highest power of 3? 3 squared. What's my highest power of 5? Just 1, so a 5. If I multiply these three, which were the highest power of each of these factors of each of my three denominators, if I multiply them, that's 4 times 9 is, let's do it this way. 2 times 2 is 4. 3 times 3 is 9. 4 times 9 is 36. 36 times 5 is not 180. What did I do? 3 squared times 5. 3 times 5 times 2. 2 squared. 2 squared, 3 squared, 5. 4 times 9 is 36 times 5. Oh, it is 180. 36 times 5 is 180. Sorry, my brain went nuts for a second. So it is 180. Okay, so that's it. 180 is the common denominator. So you can factor them, and I'll show you that with some binomials that'll make it easier. That if you factor the denominators and look for the highest power of each, and then multiply those together, you'll get your least common multiple, which is your least common denominator. If we want to find the least common denominator of these, which involve variables and binomials, you can apply the same principle. So I'm going to look at these two fractions, and I'm going to figure out what the least common denominator is for these. First, I factor each denominator completely. So my first denominator, 6x minus 30, I see that 6x and 30 are both divisible by 6. So I'm going to factor out that 6, leaving me with x minus 5. For 9x minus 45, I can see that I have a common factor of 9. You see that? So I'm going to factor out a 9, and I'm left with x minus 5. Now, if I want to figure out what my common denominator needs to be, I'm going to do what I did in the last problem. I'm going to factor down to prime factorization each of these. So 6 can be 2 times 3. 9 can be 3 squared, or 3 times 3. These are still, we're looking at my two denominators factored all the way out. But if I take my greatest common or greatest power of each of these, what's the greatest power of x minus 5? Just one. There's only one there and one there. What's the greatest power of 2? 2. What's the greatest power of 3? 3 squared. So 2 times 3 squared times x minus 5 is going to be my least common denominator. Do we see what we did? We started with our denominators. We factored them all the way. Here I just factored out a monomial term. Then I factored the coefficient or the constant integer, the 6 and the 9. Then I looked at all of them and said, what are the factors? 2, 3, and x minus 5. They share 3s. They share x minus 5s. So I only take the highest power of each of the shared factors because we're looking for a common denominator, which means we need common factors. So the highest power of 2 was 2, the highest power of 3 was 3 squared, and the highest power of x minus 5 was 1. My least common denominator, if I go ahead and multiply these, now that they're together, I'm going to multiply them. It'll be cleaner. 3 squared is 9. 9 times 2 is 18 times x minus 5. So this is my new, simplified, streamlined, least common denominator. So far in those examples, all we were doing is finding the least common denominator. We weren't rewriting the fraction with the new least common denominator. But let's try that. Let's take this just a step further. 9 over x squared minus 8x plus 16. And our other fraction that we want to get a common denominator with is 5 over x squared minus 7x plus 12. So now I'm going to factor the denominator completely. If I do that with x squared minus 8x plus 16, I get x minus 4 and x minus 4. Again, I was looking for factors of 16 that will add up to negative 8. Well, negative 4 times negative 4 equals 16. Negative 4, negative 4. Negative 4 plus negative 4 also equals negative 8. And x times x equals x squared. So I'm confident that I factored that correctly. That leaves me with x minus 4 squared as my factored denominator for this first fraction. Now we want to get to a factored denominator for this fraction. So we have to factor x squared minus 7x plus 12. When I factor that, I get x minus 3, x minus 4. I know that's right because that gives me 12. Then that gives me x squared, and the negative 3x and the minus 4x give me negative 7x. So it checks out. I factored it correctly. X minus 3 times x minus 4 is my factored denominator for my second fraction. So now I look at these two denominators, and I haven't changed their value. I just factored them. And I ask myself, what's the greatest power of the common factors that we have here? Well, of all the factors. So we have to have an x minus 3 because each factor needs to be represented. There's an x minus 3 here, so I need x minus 3 in my common denominator. There's also x minus 4. What's the highest power of x minus 4 here? That's right, it's x minus 4 to the second. So my common denominator, my least common denominator, because that's what we're trying to get here, it's easier to work with, is x minus 3, the quantity x minus 3, times the quantity x minus 4 squared. That's my common denominator. Now, if I want to rewrite each fraction as an equivalent fraction, we haven't done this yet with these polynomial fractions, but let's say we wanted to take this fraction and this fraction, and write them with the common denominator, x minus 3 times x minus 4 squared. We've got to set this up as so. So we have 9 over x squared minus 8x. Oh, wait, let me go ahead and write the new factored. Sorry about that. 9 over the common denominator. That's why we figured out the common denominator, so that we could create I gotta write the original factored one. So the original factored one was x minus 4, x minus 4. Let me erase this. Put the 9 over top of the original. This is the new least common denominator. This was the original, but it was factored. Now, how did I get from x minus 4, or we could write that as x minus 4 squared, right? Because there were just two of them multiplied times each other. This makes it look really obvious. How did I get from this original denominator to this one? What did I multiply the x minus 4 squared with to get x minus 3 times x minus 4 squared? Well, yes, it's fairly obvious. Should jump off the page. I multiplied x minus 3 right here. So that means I have to multiply 9 times x minus 3 in my new fraction with the common denominator. All right, so that's the first fraction. I know I went from right to left. That was silly, but I'll go from right to left on this one too, so it's not too confusing. So the original fraction was 5 over, we want to use the factored version, x minus 3 times x minus 4. That's the factored version of this original denominator. So now we've got that factored version, and we want this fraction that we started with to be in an equivalent fraction, but we want it with the new least common denominator that we came up with. The least common denominator that we came up with was x minus 3 times x minus 4 squared. So in order to get from this original denominator to this new one, what did we have to multiply this denominator by? We already had the x minus 3, so it's not that. We already had x minus 4, but we didn't have x minus 4 squared. So that means that we multiplied times x minus 4. And since we multiplied the old denominator by x minus 4 to get to this new common denominator, we must multiply the numerator, or 5 times x minus 4. So now we have our new fractions are these. I know, I put them on the left instead of the right. But our new fractions, which are equivalent to the originals, but now have the same common denominator, are 5 times x minus 4 over x minus 3 times x minus 4 cubed, and 9 times x minus 3 over x minus 3 times x minus 4 squared. I said cubed on the last one, but I meant squared. Now, if I wanted to, because those two fractions now have a common denominator, I could add or subtract them. That's actually the whole point of this first lesson, section 6.4. So when you do this homework, right here, 1 to 43 odd, you're just finding common denominators, and then you're writing the new fractions with the same common denominator. In this next section, 6.5, we're actually going to add or subtract the new fractions that we created with a common denominator. So I'm going to do some examples that are from section 6.5 so that you can see how we subtract these once we get a common denominator. Now, if you already have a common denominator, for example, 3c over 10 or 16 plus 5c over 16, when you add or subtract a fraction, you always leave the denominator the same. You only add or subtract the numerator. So 3c and 5c is 8c. Now I'm not quite done because I'm not just writing equivalent fractions here. I'm not just finding a least common denominator. I'm actually adding and subtracting. So once I finish my adding and subtracting, I do want to simplify as much as I can, either factoring or reducing. So here I can reduce because 8 and 16 have a common factor, many common factors, but we only go for the greatest common factor because it makes the reducing quick, right? So 8c divided by 8 is c, and 16 divided by 8 is 2. So our answer of 3c over 16 plus 5c over 16 is c over 2. Pretty simple when the denominators match. It's straightforward math. Here's another one that has a common denominator already. 5x plus 4 over 10 minus 3x minus 8 over 10. Well, same denominator, so we don't have to mess with that. We leave it alone. The number of slices of the pie stays the same. We only mess with how many numbers of slices we're going to eat in the top out of the whole. So let's deal with our numerator. We have to go ahead and combine our like terms in the numerator. So to do that, we're going to combine them all together. 5x plus 4, and we're going to subtract 3x minus 8. That's all over 10. So we've rewritten our problem as a fraction. We're just leaving the denominator alone, and we're subtracting at the top. Well, we have to follow order of operations in the numerator. How do I get rid of these parentheses? Well, I multiply by a -1. If I multiply by a -1, I can get rid of the parentheses. Now, when I'm adding this 5x plus 4 up here, I don't have to multiply by a -1 because you can just add from left to right. You're gonna basically get the 5x plus 4 added together before you subtract the 3x and the -8. Because you always go from left to right with addition and subtraction. So I don't have to multiply a negative for 5x plus 4. But I do have to take this negative here and multiply it within. So if I multiply -1 times 3x, I get minus 3x. And if I multiply it times -8, I get positive 8. All that over 10. So now I can just go left to right because that's what you do with addition and subtraction. As long as you combine like terms only. So 5x minus 3x is 2x, and 4 plus 8 is 12, and the common denominator stays the same. Can I factor still? Yes, I can still factor. So 2x and 12 have a common factor of 2. Leave me with x plus 6, and I have 10 on the bottom. Can I still reduce this? I can, because these are factors. I can treat them separate from each other. So I can reduce 2/10 and not worry about the x plus 6. So if I reduce that, I'm left with 2 divided by 2 is 1, which I'm just not going to write there. It's x plus 6. And 10 divided by 2 is 5. So x plus 6 over 5 is the answer to this problem right here. Again, in that example, we had a common denominator to begin with. We need to do one where we don't have a common denominator at the beginning. Let's try one of those. So what if we had 2 over x minus 3 plus 7 over 3 minus x. These denominators almost look the same, but they're not. How do I get them to be the same? Well, I have to multiply them both, or I have to multiply one of them by a -1. You can choose which one you want it to be. I'm going to choose the 3 minus x. So to get to x minus 3, I know that a -1 will do it. So I'm going to multiply a -1 times the x minus 3. Here's my -1 times x minus 3. Well, when I multiply that, it doesn't affect my 2 over x minus 3, does it? But it does affect this whole fraction. It's now going to be minus 7 over x minus 3. Sorry, I miswrote this. 3 minus x was what it was. Now it's x minus 3 because the 3 becomes negative and the x becomes positive. So 2 minus 7 is going to be negative 5. And because we have a common denominator, we're adding or subtracting. We don't do any math with the denominator. We just leave it alone. So it's negative 5 over x minus 3. You can also, with these problems, write the negative beside the fraction line, dividing the numerator and denominator. They're worth the same. Okay, let's do another one where we don't have a common denominator. So in that one, it was kind of simple. We only had to multiply a negative 1 in the denominator just to flip the signs. That's a little different than what you'll typically do when you're not dealing with just changing signs, but you have to change number values. So look at this problem. In this case, you're probably happy because there's no letters in the denominator. We do have to figure out what the least common multiple or least common denominator would be. Well, 4 and 18, you might be able to do that pretty quickly and see that 36 is a common denominator. If not, you have that, you remember you can do 2 squared, you can factor these, and you can do that'd be a 6. 6 times 3, 3 times 2. So that would be 3 squared times 2. And if you wanted to, you could look at this and figure out 36. You take your highest exponent for each, so it'd be 2 squared times 3 squared, and that's 4 times 9. And that gives you 36. So you can do that as a method if you can't do it mentally, but I just remembered 36 pretty easily. So 4 goes into 36 9 times. We multiplied 4 times 9. A times 9 has to be done because if you do something to the denominator, you need to do it to the numerator. So it's 9a over 36 is our equivalent fraction. Now we have to see what we get with 5 plus 12a over 18. So 5 plus 12a over 18. And we want to make that a fraction with 36 as the denominator. How do we do that? Well, we figure out how do we get to 36 from 18. We multiplied it times 2. Well, that means I have to do the same thing here. I have to multiply 5 plus 12a times 2. Well, that comes out to 10 plus 24a. All right, so our two fractions that we're subtracting now that we've figured out our two equivalent fractions with a common denominator, they were 9a over 36 minus 10 plus 24a over 36. Well, in order to get rid of the parentheses and combine the numerator, my 9a is fine, but I have to do something about these parentheses. So I can multiply this negative times 10 plus 24a. This is a negative 1. If I do that, I get minus 10 minus 24a over 36. Now, is there anything else to be done here in order to factor at the top? Do they have anything in common, or do we have any like terms that we can combine? Well, I see like terms we can combine in this numerator. 9a and negative 24a are negative 15a minus 10 over 36. That would be a correct answer. But if you wanted to factor, because, well, if you take a look, you still could factor. You could take out negative 5, and you're left with 3a plus 2 over 36. And that negative, if you like it like I do, that minus sign, I like it to be right here. I think that's nice. But either way, both of those are correct. So there, we did a subtraction problem where here we are, we started with two different denominators. The next thing we knew was I can't subtract these because they don't have the same denominator. So I figured out 36 was the least common multiple, which makes it our best least common denominator. So here I put it in the denominator of my new fraction. Remember, the top was blank, but I figured out that 4 went into 36 9 times, so I have to multiply the a times 9 as well, leaving 9a in the numerator. Then I did my other one. 18 went into 36 2 times. I multiplied 2 to the numerator because I have to do the same thing at the top that I did to the bottom. And when I multiplied that, I got 10 plus 24a. So then I subtracted those two right here. And in doing so, I had to get rid of the parentheses by multiplying a -1 here. And then I could combine them all right here. 9a minus 10 because of the -1 and minus 24a because of the -1 that I multiplied to get rid of the parentheses over 36. Then I combined like terms, and this cleaner answer, or I like it, I factored because it gets everything down to prime factors, which is nice to look at. Okay, only one more example for you, I think. No, okay. I'm going to do more than one. Let me skip to the most complicated one. It's actually not that bad, but this will be our last example, and this will cover pretty much anything tricky that you might see in your homework. So hang in with me for one more. So we're going to simplify this subtraction problem. Maybe we'll be able to solve it into a really nice answer. Okay, here's our original problem. Do I have a common denominator? I do not. Well, since I don't, I've got to go ahead and get a common denominator. I would like to factor first. Factoring is always a good first step. I'm going to pay attention to the denominator because that's our first step. First step is get a common denominator. Everything else follows that because then I can do my subtraction. So I need to factor the denominator first. That'll make it easier to spot what our common factors are to get to our common denominator. So a squared minus 2a, I could factor an a out of that, leaving me with a minus 2. And for the fraction on the right, I see that I have a difference of squares. Isn't that glorious? So it's a minus 2 and a plus 2. Remember, that's the rule in difference of squares. I can take the square root of each of the terms, and just remember that one will be minus, one will be plus. All right, so these are my two denominators. I haven't changed their value. I just factored them. So we haven't found a common denominator yet. But now I want to find a common denominator. We look at my two denominators, a times the quantity a minus 2, and a minus 2 times the quantity a plus 2. Remember, my common denominator, I want to include all of the factors from the two original fractions. I wrote them factored to make it easier. We did that with our very first example today where we're using digits, just integers, and we were doing factoring trees. We're doing the same thing here. So between these two, we have an a. So our common denominator is going to need an a. We have an a minus 2 in each of them. So we got to capture that. Does either of them have a second or third power? No, they're both 1 power, so that's the highest exponent for that one, a minus 2. And then a plus 2 is the other one. And just to the first power, there's not another a plus 2. You always pull the highest power of each common factor. But for all of these, it was just 1. So the new common factor is going to be a times a, or least common denominator is going to be a times the quantity a minus 2 times the quantity a plus 2. So let's write that. That's our common denominator. A times a minus 2 times a plus 2. Actually, let's do it this way, because remember how I wrote them backwards last time. And let's put the original fraction on the left. So a minus 3 over, I'm going to put the factored denominator, a times a minus 2. So that is this fraction rewritten with a factored denominator that we figured out right here. Now I'm going to rewrite this one down below. A minus 4 over the factored denominator, a minus 2 times a plus 2. All right, so I just rewrote the same fractions down below. I did them with a common denominator. Now I'm going to transform them into the new fractions that we can subtract, because this was a subtraction problem. But we could not subtract these two fractions without getting a common denominator. We found our common denominator. Now we have to write it in our new fraction spots. There they are. So we're creating our new fractions right here, and then we're going to subtract them, because that was the problem. It was a subtraction problem. Okay. Here we're looking at the original factored denominator. And what did we have to multiply this denominator by to get to this common denominator? Yes, we had to multiply it times an a plus 2. So to get our new numerator, we have to multiply that times an a plus 2. So a minus 3 times a plus 2. Over here on the right, how did we get from this denominator, which was our original denominator factored, to this denominator, which is our new least common denominator that we need for our subtraction problem? Yes, we multiplied an a. So we have to multiply a times a minus 4. All right, so our new subtraction problem, we did it. Now we have two fractions that have a common denominator, and they're equal to the original fractions, so we didn't break any rules. And we're subtracting them both, or subtracting this one from the other. Okay, I still kept my common denominator. Now I've got to subtract these things. Well, to get rid of the parentheses, we may have to do something like multiply a negative. Let's go ahead and write these out. So I'm going to multiply these two binomials, because we can't combine like terms unless we get rid of the parentheses. And remember, to get our numerator all combined, we have to kind of combine some like terms. So I'm going to go ahead and multiply these, which gives me a squared minus 3a plus 2a minus 6. That was from doing FOIL with these binomials. Now that's all minus a times the quantity a minus 4. That's the other numerator. Well, if I multiply this out, then I get a squared minus 4a. All of that is over our common denominator that we're not changing. We don't mess with that. When you subtract or add with a common denominator, just leave that denominator alone. All right, well, if I want to get rid of these parentheses, I can't just do it by erasing them. I have to multiply this negative. There's actually a negative 1 here. I hate to rewrite this again, but let's do it so we capture every step. A squared, this can just be minus a, because it's negative 3a and positive 2a, minus 6. And then I'm going to multiply this negative 1. So that's going to leave me with, by multiplying that, I get rid of it on the outside, and instead I turned my a squared into a negative a squared, and I turned my 4a into a positive 4a. That's all over top of our common denominator. We're getting close. Trust me, we are. We're getting real close. So now I'm going to combine like terms. I have a squared minus a squared. Well, that's going to leave me with 0, so there's no more a squareds. I have a 4a and a negative a. That's going to leave me with only 3a. And the only number left at the top is the negative 6. And my denominator, I don't do anything with it. See, it just stays the same the whole time. You're not messing with the denominator. Okay, here's the thing. Before I'm done, I might check, do I have to factor? Not at the bottom. That's already factored. That's how we came up with the common denominator. But look at the top. I think I can take a 3, factor it out of that, and be left with a minus 2. Hopefully you agree with me. Well, at this point, now that I've totally factored and simplified, I've already subtracted, I'm allowed to mess with the denominator because this is my final answer. Now I'm just reducing, okay? This is reducing or simplifying. I see that I have a common factor between the numerator and the denominator. It's the a minus 2, isn't it? So I can divide that. I'm left with a 1, so I'm not going to write it down. And I just leave the denominator with what's left. Lo and behold, there's our final answer. Now, I know that seemed like a lot, but it's just because I was talking through every step. It won't take you nearly as long to do that yourself. But here's where we started at the top. We had 2 fractions being subtracted from each other right here. They did not have the same denominator, so we had to get a common denominator. So in order to do that, I factored each of the denominators right here so we could see their factors. We wanted to see their factors so that we could create a common denominator that pulled each of their factors to its highest degree or highest exponent. So we pulled an a, we pulled an a minus 2, and we pulled an a plus 2. None of them were squared or cubed, so we didn't have to worry about that. We just pulled them to the first power. Now that we had a common denominator, we had to take our original fractions, which we had factored the denominator in, but they were still the original fractions in their value. And we had to convert them to the new common denominator. After we did that, by looking at what we had to multiply on the denominator and then multiplying the same thing in the numerator, we wrote the answers down below. And then in order to combine like terms in the numerator here, we had to do FOIL up here with both of them. Once we did FOIL, we got this answer from that FOIL distribution. Wrote it all out, combined some like terms, but I still had to get rid of these parentheses. So I multiplied this -1, which left me with a minus a squared plus 4a. Now I had this nice clean row of terms to combine. So I combined all my like terms and ended up here with 3a minus 6. Still haven't messed with my denominator since I got my common denominator. I didn't need to. You leave that alone till you're done with the top. So I'm done with the top. Nope, I'm not, because I discovered I could factor a 3 out. So I factored my 3 out. And after doing that, because the writers of your book are always so friendly, I noticed that I had a common factor on the numerator and denominator, and I was able to divide those, leaving a 1, which left me with only a 3 at the top and only a times a plus 2 at the bottom. Okay, that's about as complex as it gets for that section. So what we learned today was how to add and subtract fractions that have polynomials. And it's the same as you do with just plain old numbers since 4th grade. You have to find a common denominator. The difference is you learned how to find a common denominator with polynomial denominators. And you have to use factoring to do that. And you had to use division of these fractions to do that. And you have to use multiplication of fractions to do that. We just combined the last chapter and the last 3 sections of your book into these 2 sections. So again, remember I scrolled back to the top here for your homework or your classwork, depending on what you do with the time you have left. I look forward to seeing you on Monday.